After watching this video, you'll be able to list the 5 practices of working Agile, explain working in small batches, define a minimum viable product, understand behavior-driven development, understand test-driven development, and explain how pair programming works. So let's take a look at what it really means to work in an Agile fashion. First, you want to work in small batches. We get this from lean manufacturing. You don't want to make a big batch of something and then find out that you did it wrong, because that's a lot of waste having to go back and change it. Next, you want to use minimum viable products to figure out what the customer likes and what doesn't the customer likes. And then you want to use practices like behavior-driven development and test-driven development to improve your testing of the system from the outside in and from the inside out. And then finally, you want to take advantage of pair programming. This came from extreme programming, but pair programming is critically important. So we're going to look at each one of these in turn. Working in small batches, let's say I need to mail out 1,000 brochures. And the steps are: you need to fold the brochures and then insert the brochures into envelopes, and then seal the envelopes, and finally stamp the envelopes with postage. So let's say that we're going to do these 1,000 in batches of 50, right? Big batches, 50 a piece, and assume that each step takes about 6 seconds to complete. So I can do about 10 steps per minute. And so we do the first step, folding, right? And at 10 for a minute, it takes me about 5 minutes to fold 50 of them. Then I move on to the next step. The next step is inserting them all, and again, if I could do about 10 of them per minute, and so it takes me 5 more minutes, plus the 5 minutes from before. Now I'm 10 minutes into it. I've got them all folded and inserted. Then I move on to step 3, sealing them all, right? So now again about 10 per minute, I could do another 50 in another 5 minutes. So I'm up to 15 minutes, right? Wall clock time. And then finally I get to step 4, and it took me 16 minutes to get my first finished product right. The first one where I had things that I could actually inspect it and see what the quality was. So, what if the envelopes had no glue? Right. It would be 11 minutes before I figure out that something went wrong. What if there's a typo on the brochure? I have to go all the way back to the beginning, right? So, this is just very, very wasteful working in these large batches like this. Now let's look at the same example with single piece flow. And again, assume each step takes about 6 seconds to complete. With single piece flow, I fold, right, and put them in the envelope and seal them and put a stamp on them, and the first finished product is in about 24 seconds. Now I can inspect it, see if it works, see if it's what I thought it was, and then let the rest of the flow rip. Now what if the envelopes had no glue? Well, I would find out after, maybe 18 seconds, right? And if there was a typo in the brochure, after 24 seconds. So it's very, very important that we don't work in too larger batches, so that we and get fast feedback and that we can pivot and understand, do we need to do something different, and then make the changes that we need to make. So let's talk about minimum viable product. First, let's understand what it is not, because there's a misconception that a minimum viable product is like phase 1 of the project, or, the first beta or something like that. And it's not. This is not what a minimum viable product is. A minimum viable product is the minimal thing that you can do to prove a hypothesis and gain learning and gain understanding. The difference between these two is that the first one is all about delivery, right? What am I going to deliver? But the second one is all about learning. What can I learn? What can I learn from putting out this MVP and get feedback, and then maybe make the next one even better? So it's important that at the end of each MVP you decide whether to pivot or persevere. Let's look at an example. Here's a team that's developing a minimum viable product for a customer that wants a car. And so, in the first iteration, they deliver a wheel. The customer's like, what am I going to do with a wheel? I can't do anything with this. Like, well, we're working iterations. We're trying to be agile here, right? And so the next iteration will give you some more. And they give them a chassis, and it's like, okay, I really can't do anything with this. And then finally, they give them a car with no steering wheel, and then eventually they get the car, right? And so they get this coupe. That team did not understand how to create a minimum viable product. They were just doing iterative development. The second team understands the value of creating an MVP. At first, they give them a skateboard and the customer's like, I asked you for a car and you're giving me a skateboard. Whoa, we're testing the color. How do you like that color red? Is that the color you want? Oh yeah, red's kind of cool, but you know it's really hard to steer. No, we'll fix that in the next MVP, and then they add a way to steer it and the customer's like, well, okay, you did give me a way to steer it, but I can't go very fast. I need a better form of locomotion, and then we'll deal with that in the next MVP. In the next iteration, they give them pedals. Somewhere along the way while the customer is riding on that motorcycle feeling the wind in their hair, they decide, I want a convertible. In the first instance, the customer got exactly what they asked for months before because they were just following a plan, but in the second instance, the customer got exactly what they desired because they were working interactively with the development team, and in the end, you develop something that's a little bit different, but it's closer to what the customer really wants. Behavior-driven development is when we describe the system from the outside in. This is usually done at an integration testing level, right? So, this is where we're taking the customer's view of the system. Usually when you're doing BDD testing, you're doing it against the user interface, right? You're doing it against the thing that the customer sees to see if the system behaves the way it's supposed to. So, if it's an e-commerce system, when I put something in my cart, does it behave the way I want? When I transfer a cart to an order, does it behave the way I want? It's really taking an outside-in approach. It's not too concerned with the things going on underneath. The cool thing is it uses a single syntax that both the developers and the stakeholders can use to describe the system and agree on the behavior of the system, on what the system does. So, let's take a look at that syntax. It starts with these BDD feature scenarios, where I say, as a sum role, so, I want to know who is this for. I need some function. So what is it the functionality that we actually need so that I get some business value? So, now you know who is it for. Is it for the customers? For the system administrator? Right. Who's getting the value out of this? What do they need and why do they need it? And that's the beginning of your feature file. And then you start running through scenarios, and here's where we use this common syntax. It's known as gherkin syntax after the gherkin pickle, and it goes something like this, given a set of preconditions, right? So, that kind of sets up the scenario given that this is true. I've got 2 items in my cart. I got 3 items that I order, whatever. When some event happens, right? So, that's the thing that's under test. Then I should see some observable outcome. So, using this given when then syntax, developers can understand it, stakeholders can understand it, everybody can understand this common syntax that when I have something in my cart and then I clear my cart, you know, I should see nothing in my cart. So very important to have the syntax in these BDD scenarios. Test-driven development is testing a system from the inside out. Unlike behavior-driven development, it is concerned with the internals of the system, the single modules. Usually this is called unit testing, and this is something that is unit test case-driven, and we want to make sure that given these inputs I get these outputs at a small module level. I don't know if when I put them all together I'm going to get the behavior I want. That's kind of BDD, but for TDD, test-driven development, I'm just testing the system way down at the unit level, and so you write a test case first for the code you wish you had, and then you write enough code to make the test case pass, and then you start all over again and refactor. So the workflow goes something like this. I write a test case. You might say, you write test cases before you write the code. Yeah, this keeps me featured on what is the code supposed to do. When I call this, how do I want to call this? What are the parameters I think I want to pass in, and then what does it do for me? So, you write the test case first, then you write enough code to make the test case pass, and then once it passes, then you can refactor the code because now you have test cases to keep you honest. You'll know if you broke anything. Now, because when the test case runs and it fails, it usually turns red, and then when it works correctly it turns green. We tend to call this red, green, refactor. Watch a test case, write a test case, watch it fail, make just right enough code to make it pass, and then refactor make it. You might not have made it very elegant just to make it pass. Now you can go back and you can add all sorts of error checking and whatnot, make it a little more robust, and then run the test cases. Make sure you didn't break anything. Pair programming. Pair programming, you might say two programmers working together on the same thing, and the first thing is, I'm paying two people to do one job. But actually it works out really, really well, because what you're doing is you've got one person writing code and then you've got another person who has another set of eyes on the code. So the question is, would you rather find bugs in production? Would you rather find bugs while you're writing the code? It's a lot cheaper to find them while you're writing the code, so having two sets of eyes, they check each other and they go back and forth. It's not just one and then the other. Usually in 20-minute increments, right? Somebody's writing code, the other one is watching, and they're not just watching. Sometimes they're looking things up, sometimes they're discussing. What do you think I should call this variable? What do you think I should call this function? Right. It's two sets of minds working around this code, and what happens is you actually get higher quality code at the end of the day, right? The code quality goes up because two people have already checked it, and so when you say, I can't afford to pay two people to write one piece of code, you can't afford not to pay two people to write it, because writing the code is the cheap part. Debugging it, maintaining in production, that's the expensive part. And so if you want the expensive part to get cheaper, you want to have your programmers do pair programming. It's also very good to put a senior programmer with a junior programmer. Now the junior programmers can see how does the senior programmer approach the problem, and so they learn, they get mentorship, and then the senior program can see how the junior person is making out. Or you get people who are unfamiliar with the code working with someone who is. Now you get more people learning the code because they're getting like a tutorial from the other person. So pair programming is really, really great way of bringing all your people on your team up to a certain level. In this video you learned that working in small batches means delivering something useful quickly, and MVP is the cheapest, easiest thing you can do to test the hypothesis and learn. Behavior-driven development makes sure you're building the right thing, and test-driven development makes sure you're building the thing right. While pair programming enables you to discover defects earlier and increase your code quality.